Welcome to Precalculus Lesson 3.8, Trigonometric Equations. Trigonometric equations. Any equation that involves trigonometric expressions is called a trigonometric equation. Recall that a solution, or a root of an equation, is a number in the domain of the equation that, when substituted to the variable, makes the equation true. The set of all solutions of an equation is called the solution set of the equation. This lesson on trigonometric equations is different from the previous lesson on inverse trigonometric functions, since the last lesson is all about function and this lesson is all about equations. Before going through our main lesson on solving trigonometric equations, I have here preliminaries for you to consider. Let us solve first some basic equations. Number 1, cosine x equals square root of 3 over 2. Find the value of x. In the previous lesson, what we did is, in solving for the values of x, we actually restrict the possible values for its corresponding range. That's for the inverse trigonometric function. But for today's lesson, it's all about equations. So basically, what I'm trying to say is the value for x for today's lesson will be all of the values in the unit circle, all real numbers. That's our domain. So for number 1, cosine x equals square root of 3 over 2. The possible values of x that will yield a cosine of square root of 3 over 2 are pi over 6, also 11 pi over 6. Also, if we proceed to more than 2 pi, we have 13 pi over 6. We also have 23 pi over 6, and so on and so forth. That's for today's lesson on solving trigonometric equations. Number 2, sine x equals 0. Find an angle x such that the sine is 0. So, of course, I will draw a circle on my scratch paper and then locate the all possible values. So that's 0, pi, so on and so forth. 0 pi, we also have 2 pi, 3 pi, 4 pi, 5 pi, so on and so forth. This preliminary exercise will be very useful in today's lesson on solving trigonometric equations. Now for the examples. Find all solutions of each equation for, take note, for the given interval. So our answers should be part of the interval. Number 1, cosine squared x equals 1 such that x is greater than or equal to 0 but less than 2 pi. To solve this one, my technique is I will make the right hand side of the equation be 0. So I will use subtraction property for number 1. We have cosine squared x minus 1 equals 0. Take note, cosine squared x minus 1 could be 1 squared, since 1 squared equals 1. I did this one because I will use the difference of two squares identity. What is difference of two squares? Say we have a squared minus b squared. The factors of this one are quantity a plus b times the quantity a minus b. Applying this identity to our example, we have cosine x plus 1, that's first quantity, times the second quantity cosine x minus 1 equals 0. Using the zero product property to find the values of x, we have two parts. First, cosine x plus 1 equals 0. Second part, cosine x minus 1 equals 0. and then solve for x. So we have two sets for the possible values of x. First part, cosine x equals -1, applying subtraction property. Now, solve for x. How do we solve for x? Find an angle such that the cosine is -1. I will draw a scratch unit circle. Do not forget that our answers for x should be part of the interval x is greater than or equal to 0 but less than 2 pi. So for number 1, the values of x that will have a -1 cosine is x equals pi. For the second part, solve for the values of x. So what I will do for the second part, I will use addition property, adding 1 to the both sides. So I got cosine x equals 1. Find an angle such that the cosine is 1. That angle is 0. X equals 0 is another root. So the solutions are x equals 0 and x equals pi. Final answer. Example number 2. Solve sine 2x equals 2 cosine x such that x is greater than or equal to 0 but less than 2 pi. For number 2, we need to find an identity for sine 2x. How do we do that? We need to apply the double angle identity for sine function. This identity is, if we have sine 2x, the equivalent identity is 2 sine x cosine x. Applying this to the problem, we have sine 2x becomes 2 sine x cosine x equals 2 cosine x. Applying subtraction property such that the right hand side of the equation becomes 0, we got 2 sine x cosine x minus 2 cosine x equals 0. Take note, we have common factor which is 2x for the both term. What remains in the first term is sine x and the second term is -1 equals 0. Using the zero product property, we have 2 cosine x equals 0, first part, and then the second part, sine x minus 1. Solve for x. First part, divide both sides by 2. We have cosine x equals 0. Find the value of x. Do not forget the interval. X is greater than or equal to 0 but less than 2 pi. Our final answer should only be part of that interval. So for the first part, the x values are pi over 2 and 3 pi over 2. That will yield a cosine of 0. Second part, sine x equals 1, applying addition property. Solve for x. Find an angle such that the sine is 1. So the value of x is pi over 2. We have pi over 2, 3 pi over 2, and pi over 2. The solutions for number 2, we have x equals pi over 2 and 3 pi over 2. Note that if an equation cannot be solved easily by factoring, try rewriting the expression using trigo identities. However, using identities in some algebraic operations such as squaring may result in extraneous solutions, so it is necessary to check your solutions using the original equation. Basically, if we use an identity in simplifying or factoring the given equation, if ever we have to cancel out some trigonometric expression, then for sure, the final answer contains an extraneous solution, which we need to check all of these solutions with the original equation. Say for example, I have sine x times cosine x times tangent x, which is part of my trigonometric equation, then I will simplify this one. How is having the identity of tangent x. Then I will cancel out cosine x over cosine x. because that's equal to 1. If you happen to cancel out a trigonometric expression, expected that there is an extraneous solution in your answers. Going to example number 3. Solve cosine x times tangent x minus sine squared x equals 0, such that x is greater than or equal to 0 but less than 2 pi. So for this case, I will simplify tan x. So cosine x times sine x over cosine x minus sine squared x equals 0. And then simplify, we have cosine x over cosine x is 1. What remains is sine x minus sine squared x equals 0. The common between the two terms is sine x. Factor out. First term remains 1 and the second has negative sine x equals 0. Using zero product property, we have sine x equals 0, and we also have 1 minus sine x equals 0. Solve for x. For the first part, x equals, so I'll draw a small circle to locate. Do not forget that our possible answers will only be from x is greater than or equal to 0 but less than 2 pi. So for sine x equals 0, x equals 0 and pi. So these are the angles that have a sine of 0. For the second part, 1 minus sine x equals 0. So we have negative sine x equals negative 1. Multiply everything by negative 1. Sine x equals 1. X equals pi over 2, since this angle has a sine of 1. Take into consideration that we cancel out cosine x, which is a trigonometric expression. That is why there is a need for a checking, since one of our answers is an extraneous root. So check for the 3, 0, pi, and pi over 2. We'll start with x equals 0. All we need to do is to substitute 0 to the original equation. Cosine 0, tan 0, minus sine squared 0 equals 0. We'll check. Cosine 0 is 1. Tangent 0, it's 0. Minus sine 0, 0. Squared equals 0. Simplify. 1 times 0, 0 minus 0 squared equals 0. So x equals 0 is an answer. Next, x equals pi. Check. Substitute pi to the original equation. We have cosine pi, tan pi, minus sine squared pi equals 0. So let's check. Cosine pi is negative 1. Tangent pi is 0. Sine pi, that's 0. Squared equals 0. Simplify. Negative 1 times 0, 0 minus 0, 0. 0 equals 0. X equals pi is a root. Third, x equals pi over 2. Substitute to the original equation. Cosine pi over 2, tangent pi over 2, minus sine squared pi over 2 equals 0. We need to check this one. Cosine pi over 2, that's 0. Tangent pi over 2, that's undefined. Minus sine pi over 2, 1 squared. Take note, tangent pi over 2 is undefined. Therefore, we can already say that pi over 2 is an extraneous root. Therefore, the solutions are x equals 0 and x equals pi. Final answer. Proceeding to example number 4. Solve 2 sine squared x minus 1 equals 0 such that x is greater than or equal to 0 but less than 2 pi. To solve this one, take note, we need to remember to not cancel out trigonometric expressions such that there is no extraneous root at the end. To solve this one, I will find an equivalent value for 2 such that it is a square. So that's square root of 2 squared, which is 2. Copy sine squared x minus 1. 1 is just equal to 1 squared. I did this one because I have in mind to use an identity that we've already used in the previous, which is the difference of two squares. So we have square root of 2 sine x quantity square minus 1 square equals 0. We can apply the difference of two squares. The difference of two squares is if we have a squared minus b squared, then we can simplify it through a plus b times a minus b. Applying to our given, we have square root of 2 sine x plus 1 times the quantity square root of 2 sine x minus 1 equals 0. Using zero product property, we have two possible sets of answers. First, square root of 2 sine x plus 1 equals 0. The second part is square root of 2 sine x minus 1 equals 0. Solving for x for the first part, we have square root of 2 sine x equals negative 1. Applying subtraction property, divide everything by square root of 2. That becomes sine x equals negative 1 square root of 2. Rationalize, multiply square root of 2 over square root of 2. Sine x now becomes negative square root of 2 over 2. Solve for x. Find an angle such that the sine is negative square root of 2 over 2. Do not forget that our final answer should only be in the interval x is greater than or equal to 0 but less than 2 pi, or from 0 to 2 pi, 0 inclusive. So to find, I'll draw a scratch unit circle and then locate the possible angle, which is a sine of negative square root of 2 over 2. So that's basically 1, 2, 3, 4, 5. So that's 5 pi over 4 and 7 pi over 4. So we have two answers for the first set. The second one, square root of 2 sine x equals positive 1. We use addition property and then divide both sides by square root of 2. Right after, we rationalize by multiplying an equivalent of 1, which is square root of 2 over 2. Simplify, we have sine x equals square root of 2 all over 2. Find an angle such that the sine is square root of 2 over 2. The angles are pi over 4 and 3 pi over 4. So we have 4 answers for this one. Take note, we did not cancel out any trigonometric expressions. So our final answer for number 3, the solutions are x equals, in ascending order, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. For our last example, number 5, solve 2 cosine squared x equals 1 plus sine x such that x is an element of 0 to 2 pi, 0 inclusive. Do not forget that this is just equivalent to saying x is greater than or equal to 0 but less than 2 pi. So to solve for number 5, first, we need to have it in a way that the right hand side is equal to 0. So we need to use subtraction property for this one. We have 2 cosine squared x minus sine x minus 1 equals 0. Now, we need to simplify the cosine squared x such that the constant or the uniformed trigonometric expression will only be sine x. Take note that cosine squared x can have an identity which is in the Pythagorean identities, which is the sine squared x plus cosine squared x equals 1. Then cosine squared x is just equal to 1 minus sine squared x. Using the identity, we have 2 times the quantity of 1 minus sine squared x minus sine x minus 1 equals 0. Simplify. Distribute 2. We have 2 times 1, that's 2, minus 2 times negative 2 sine squared x minus sine x minus 1 equals 0. Now, arrange the equation in descending order in terms of the degree. So we'll start with negative 2 sine squared x minus sine x, 2 minus 1, that's plus 1 equals 0. Multiply negative 1 to the whole equation. We have 2 sine squared x plus sine x minus 1 equals 0. Now, how do we solve this equation? Take note, 2 sine squared x plus sine x minus 1 equals 0 is the same as like a quadratic equation, in which a quadratic equation has an equation of ax squared plus bx plus c equals 0. The same as our current solution now, wherein x is sine x. So what I will do is I will let sine x be a certain variable. Say, let z be sine x. Substituting sine x with z, we have 2z squared plus z minus 1 equals 0. Then we can easily get the value of z through factoring. So how do you factor this one? Use your knowledge in junior high school. Factors of 2z squared, we have 2z and z. Factors of negative 1, we have 1 and 1. And then the sign is first part negative, second positive. That's equivalent to 2z squared plus z minus 1. Using the zero product property, we have 2z minus 1 equals 0. The second part, we have z plus 1 equals 0. First part, we have using addition property, we have 2z equals 1. Divide both sides by 2, we got z equals 1 half. For the second part, z plus 1, we have z equals negative 1 using subtraction property. Take note, z is just equal to sine x. Substituting z with sine x, we have sine x equals 1 half. And also, sine x equals negative 1. Then we can solve for the values of x. For the first part, find an angle such that the sine is 1 half. I draw a unit circle in my scratch. That part is pi over 6 and 5 pi over 6. Do not forget to consider the interval. Second part, x equals, find an angle such that the sine is negative 1. The answer is 3 pi over 2. So we have 3 answers, which is part of the given interval from 0 to 2 pi, 0 inclusive. So for our last example, the solutions are in ascending order still. X equals pi over 6. We also have 5 pi over 6 and 3 pi over 2. Final answer. That's it for lesson 3.8, trigonometric equations. I hope you learned something from this video tutorial. This is really intended for my STEM students in Consolacion National High School Day class, senior high school. But since I posted this one in YouTube, and if you happen to watch this video tutorial, I hope you learn a thing or two. Thank you, and do not forget to like, share, and subscribe.